All right. Yesterday I mentioned that once you balance an equation, it's not a mass relationship. Not a mass relationship. Talked about the number of molecules and the number of atoms on each side have to be conserved unless you want a explosion, which is also called a nuclear bomb, by the way. Okay, so what I'm going to talk about today is something called a mole. And the word mole comes from molecule. Now, if we took, now atoms are really tiny guys. If we took 6.02 times 10 to the 23rd atoms of carbon, they would weigh 1201 grams. That's called a molar mass. 6.02 times 10 to the 23rd. Okay, that mass is called a mole. So we have a couple more conversions. We've got the molar mass or atomic mass. When we're talking about a molecule, it's a molar mass. If we're talking about an atom, it's an atomic mass. Okay, grams per mole, mole per gram. And this is extremely specific per chemical. It's not universal. There is not one universal molar mass or atomic mass. It depends on the chemical. Okay. The 602 times 10 to the 23rd per 1 mole is universal. In fact, the reverse, of course, is true. Now, and this is also called Avogadro's number, because he discovered it. Now it's just a counting, it's just like dozen. You can have a mole of chickens, you can have a mole of atoms, you can have a mole of students. It's just a counting number. So when you see the word in a problem, how many flag Avogadro's number? How many molecules of water are in 10 grams of water? Okay, you use Avogadro's number. So, gases. Gases are very unique because the distance between a gaseous atom or molecule and another atom or molecule is great compared to liquid or solids. And because of that, gases are compressible. That's why you always have gas pressure. They're compressible. So in all gases, no exceptions, there is 22.4 liters in 1 mole. All gases. Now, the gas has to be at standard temperature and pressure. Otherwise, it's not 22.4. It's going to be something else. Now, we're going to do a little sub-unit on gases. I'm going to talk about gas laws. So you might ask yourself, well, what if it's not at standard temperature and pressure? How do you calculate it? Then we use the gas laws to do that. Okay, so pressure is 1 atmosphere. Temperature is 0. Now, there are other standard temperatures and pressures in different units. For example, many pascals for pressure or millimeters of mercury. There's a lot of different ways of measuring pressure. But in our class, it's going to be 1 atmosphere, 0 degrees centigrade. Okay, so those are 3 conversion factors and their inverse, of course. So that means the inverse here is going to be and that's big L now, not lowercase l. Big L. Sounds like a gangster name. Big L's down the road. Better watch out. Of course, I just recorded that. I'm sorry. Okay. Now this problem here, we went over yesterday. Okay, we balance this equation. Now, when we combine molar mass and balanced equation, we have something called stoichiometry. That's the analytical relationship between reactants and products. Remember, we started unit 1, we had the 4 steps. Step 1 was balance the equation. Step number 2 is what's given. Step number 3 is what are you trying to calculate? And then the last step was the setup with conversion factors. Now, that is stoichiometry. Every single stoichiometry problem is going to be done the same way. And I'm going to keep pointing this pattern out so that you'll click in. Same pattern. Same pattern. Okay. All right. So let's look at some problems. Let's say, I can type it out. How many moles of water are in 12.1 grams of water? Okay, so what's given?
Oh, 1 gram.
Yep. What are we trying to calculate?
How many moles?
Moles.
There, 12.01 is 1 mole.
And we're talking about,
Oh, never mind. I jumped again.
okay, so what are we going to use to convert grams to moles? That's for carbon though. Hence the C. So you weren't jumping the gun.
Shoot.
Okay, so what are we going to use to convert grams to moles? We need a conversion factor. Which conversion factor are we going to use? Is there a conversion factor that has grams and moles in it? Yes. That's the molar mass. So we're going to use the molar mass, which has grams and moles in it. No. We're not going to use Avogadro's number. Because that is how many? Grams has to be in the bottom so it cancels. Okay, so how many grams are 1 mole of water? How do we calculate that? Okay, first of all, we need to know a very secret formula for water. What's that? H2O, very secret. How many hydrogens are in the water? Formula. 2. And based on the periodic table, what's the molar mass of hydrogen? (101). And we have 2 of them. All right. What about oxygen? We have 1 of them. And what's the molar mass of oxygen? Yeah, it's 16. So if you have a handy periodic table, you might want to whip it out. So we're going to add this up. 2 101s is 202 plus 16 is 1802 grams per 1 mole. For water only. Only valid for water. Okay, so that's 18 on the bottom. Oxygen 16. There are 2 hydrogens, each one weighs 1.01 grams.
There's 2. I get it.
Yeah, there's 2 of them, exactly. Okay. So grams cancel. So sig figs, we got 3, 4. So our answer is going to be 3. So it's okay. Now, based on our unit 1 calculations, this is very straightforward. It's just new units we're using. And this is why test 2 has almost all of unit 1's stuff in it. That's why it's an easy transition to have test 1 integrated into test 2. Okay, are there any questions about this? Now, the part that's different is finding the molar mass of water. We've never done that before. Now, under test 2 is going to be having quite a bit of material in it. I'm going to give you a periodic table to use with it. You're also going to have to be drawing on the periodic table, pointing out metals and non-metals and all that stuff. So obviously I'll have a study guide and a practice test. Okay, so let's do some more problems. How many molecules of water are in 12 grams? Okay. Same approach. What's given? Same thing, 12.1 grams. Now I'm going to put water up here. Because on next Friday, you're going to be required to put H2O in our calculations. Above the number. Okay, and what are we trying to calculate? How many? That's the key word. How many? Automatically think Avogadro's number when you see that word. How many? We're going from grams to molecules. So let's go to our conversion factor. And do you see? Well, there's Avogadro's number. That's per mole, though. Per mole. So we can't go directly from grams to number of molecules. We have to go to the second conversion step. And what's the commonality between grams and number of molecules? It's moles. Moles, think of moles as the glue, the pegadura of chemistry and physics and engineering. Huh? Yep, exactly. Mhm. So the intermediate, I have a saying that we're going to be using the rest of the semester. If in doubt, convert to moles. Because moles is central to everything. So if you can get it to moles, then from moles you can go all these different places. Think of it like a spoke on a bicycle. The axle is going to be moles. So you have one way to get to moles, and from moles you can go anywhere you want. Okay, so step one is moles. And we've already done that. Right here. Now we're going to go moles to the number of molecules. So mole has to cancel. And I'm going to be using railroad tracks more and more instead of parentheses. You can still use parentheses. It's just that I think it's cleaner with railroad. Okay. So this is just like Unit 1 stuff. I'm looking at 3, 4, 3 sig figs. So answer is going to be 3 sig figs. So 404 times 10 to the 23rd molecules of water. Okay, did everyone get my answer?
What was your or yes? So it'd be for like, water from the pools at the end, or Lions Airport, Lions the 23rd, H2O. That's how I write it.
Lots of them,
Yeah.
lots of them. Okay, so let's do some more problems here. Yeah. 3 sig figs. Now, I put that on all my answers, the sig figs, just for clarity. And you can do that if you want. You don't need to though. You don't want to do it. So, how many liters of gaseous water is in 12.1 grams of gaseous water at STP? Now, it's at STP in this class, gaseous water. I mean, gases, I should say. Except for the little sub unit we're doing on gas laws. Other than that, it's always STP, and I'll always try to remember to put it in. But if I don't put STP in, put it in. Just assume it's 22.4 liters per mole. Okay, so we're going back to our what's given. This is like a scratch CD. Okay, so if in doubt, convert to moles. So let's get our grams into moles. So our given cancels. Now we're going to look at conversion factors for gaseous liters. Okay, so that's 22.4 liters per mole. So our mole has to cancel. So it's going to be on the bottom. So and 3 sig figs again. So that's 15.0 liters of steam. And again, it doesn't matter what gas we're talking about. We could talk about uranium hexafluoride gas, which is what Iran is doing right now as we speak, using uranium hexafluoride gas to make enriched uranium as we speak. We also did the same thing in Hanford, Washington. During World War II, that was part of the Manhattan Project. Okay, are there any questions about these guys?
So they're gonna answer about 1.50. instead of. Why was the recipients going to give time?
You have a little e at the end,
Yes,
that's 10 to the 1.
I got the one that you told me is 36.
Yeah.
It's the MC.
Okay, so let's try a little different approach to this. Any questions about this guy? Okay. If we have if we have 10 bikes, and I asked you, how many wheels do I have? How would you do that problem? Huh?
10 times 2?
10 times 2. Why'd you multiply? Why didn't you divide?
It's multiples of 5, so that's why.
Yeah, we need a conversion factor, don't we? So 10 bikes is given. Trying to calculate number of wheels. The conversion factor is 2 wheels per bike. And that's why we multiply. Because the bikes have got to cancel. Now, all of you did that in your head, I know. Let's do chemistry with that same process. How many hydrogen atoms are in 12.1 grams of water? Now, this is the same type of problem as bicycle wheels. We need another conversion factor. And the conversion factor is going to be similar to that. Okay, so we're given again is 12.1. Okay, so let's get, if in doubt, convert to moles. What's our next step? Huh?
That's all the wall.
Well, moles got to be per mole because a mole's got to cancel, right? What's the next conversion factor we're going to use? Say again? That'll give us molecules. Okay. Now, I didn't ask you for molecules, I asked you for hydrogen atoms. This is going to give me bikes. What did I do to bikes to get wheels? That's our bike. Now we need a conversion factor to go from molecules to atoms. Just like we needed a conversion factor to go from bikes to wheels. So molecules have got to cancel. And there's 2 H atoms per 1 molecule. That's the conversion factor we need to get us to atoms. If you look at the formula, you gotta look at the formula here. If you don't know the formula for the molecule, can't do this problem.
That 6.02 times 1/3.
That's how we're calculating molecules. Then we need to go from molecules to atoms. Or 1 molecule of water.
So. Per 1 H2O. Nitrogen and oxygen. I'm still.
Okay. How's everyone doing on this one? This one's a little different. So 3 sig figs again. What about the sig figs on this? Hmm? Exactly. Sorry, you used to.
Exactly.
Yeah, it's not 2.1, it's not 1.9, it's exactly 2. So that's infinite then. So all these others are 3. So our answer is going to have 3 sig figs.
Did something wrong. I started.
Oh my God, who that? 8 points away. Yeah, that's what I got soon.
Now, wait a minute. The answer I got didn't make sense.
Yeah.
Yes, I got the same thing as you guys. Okay.
And why do you think it is that you got the other answer?
Sorry, what?
Right. So why do you think it is that you got the other answer first? Like, did you, what part of the process?
I knew the answer had to be bigger than
Yeah.
602 times 10 to the 23rd. I got 10 to the 22, so I knew I did something wrong. Yeah.
Times 2.
Okay, say this problem's worth 10 points. That's 9 points. 1 point. Okay, 90% of the points goes to setup. So had I been a student taking my test and put on that wrong answer, I would have went -1 for this problem. Because the setup is the important part.
Well. This is the workflow. What? You much.
Okay, so let's, I've really done examples of all the problems you're gonna be running into regarding conversions. Now, our next unit 3 is on solutions. And you'll be learning some more conversions, but the setup is gonna be basically the same. Is there a chemical reaction? If there is, balance the reaction. What's given, what are you trying to calculate? And then there's the conversions to go from given to calculate. Okay. Let's do one more problem. And then that's going to be it for today. I'm going to go to lab and start on that. Okay. All right. I gotta come up with a problem.
Times 2. You're eight. So the smaller
Okay. How much does 1 molecule of water weigh? Not a lot. Okay, so what's given? 1 molecule.
Well,
So what do we do next? If in doubt, refer to moles. Okay. So we need to get moles. Now, we're counting now. What do we use when we count? What conversion factor? Good old. Who in here goes to Trader Joe's? Okay. Frequently, Trader Joe's, I had a friend that used to work at corporate for Trader Joe's. And she was a new product developer. And all the cute sayings at the Trader Joe's store, she used to come up with those. Like she would have avocados, guacamole, and stuff, avocados. A lot of cute sayings like that. It was a really kind of fun person to talk to her. And it's in Southern California corporate. I think in Pasadena, somewhere around there. Okay, so we're counting. So counting, we're thinking Avogadro's number. By the way, that was the transition. Oh, I got Trader Joe's. Yep. Okay, so this will give us how many moles? Now for moles, where are we gonna go? Grams, okay? So moles has to cancel. All right, we're there. Molecules to grams. And we're looking at, now sig fig wise, this is gonna be kind of interesting. How many sig figs is one? Is it 1.1?
No, it's infinite.
Infinite, that's right. Good. So 2.99 times 10 to the minus 23 grams. That is 22 zeros in front of that two. That molecule doesn't weigh much.
Oh, I thought it was supposed to be one sig fig.
Hmm?
I thought it was supposed to be one sig.
That's why we're gonna try this.
Changes, it's like one sig fig, so 3 times. No? I don't know.
Because the one molecule we start with infinite sig figs. Otherwise it'd be one. Okay, so this ended up being a simple problem, but it was kind of hard to get started. Okay, so now it's crucial that yesterday's balancing the equations you have down for next Friday. Secondly, it's crucial you have what we covered today down by next Friday. The reason is we're going to combine these two together. And we're going to be able to solve that problem on top, up top. Because we can't solve this yet. Because we haven't put the equations part and the conversion part together yet. That's what we're gonna do on Friday. Okay, so where do you get practice? Hmm?
Worksheets.
Oh, yes. Yes, worksheets. Where are the worksheets?
Somewhere
You
there.
all know the answer.
Everything that's what I find it.
I like questions.
Just. Put it up with its statements.
Oh, so you,
Well, I'm looking at it right here. It's right, right there. So it'll be, March 21st.
Oh.
March 20th.
Well, that's gonna be on Saturday.
It's always a Saturday. That way I could review on Friday. Now, I'm old.
I, well, she very much remember you. So when she, we're going through like work, she did that. She always said, well, the way that. It's funny when you say you do things different than other teachers because she says it's gonna be. So and I just bring just that like you did that. But I imagine they're doing it too. It does take Tuesdays and Thursdays.
Okay.
And she's really helpful because we go over it and I get it, it's fast, and then when I'm trying to do this, I lose everything. I'm old kids.
Not as old as me. I'm, yes, I was born in 1950. It puts me 70. And I'm 76. Well, my doctor told me to took that. No, I'll be working, we teach in one class there. Right now I teach one there and one here. I'll be doing just the, but the same class over there is called Chem 300. And I've taught that before. In fact, that was the first class after I came down from Washington that I taught. It was Chem 300. Yeah. Good night. Yeah.
I just-
No safety. Okay.
Yeah, I just forgot to get fire sound.
In the table.
Did I get the yeah.
And then. Now, I think. Oh, okay.
Thank you.
Okay. You also have oh, my mom took like this.
Right. You have one. I'll send it to you. No, this is. Perfect.
Yes, okay.
Like it's legible as a movie. Nice.
And I get that, when I say the bed that I have for kids, that I put in when we and so I tried to look it up, so it just means like I either way, when he didn't make us pick out some cereal boxes because he doesn't know Jim's house. It's
You're doing two signatures. One. You're doing pretty loud. Please.
Design.
Everything that's proposed.
And here.
Okay. There are two things you need to do. One is wait up. You can sign that, hopefully. Or sign. Put that as a packet for. And the other is the last signature. So if you go to file, let me show you. If you go to files, lab related.
Moving. Oh no, it's someone else's page. Okay, are you? I mean. If I could, that'd be great. I'll just do this.
Here's the contract here at the bottom. And then. Where else? Wait here. Oh, I know, the school does it differently. There is an additional course. This is gonna sound funny. See this liability release? You should have that. Yeah, so go into there and it's just a matter, and you submit it, it automatically signs up for you. So do those two things. See you in a little while.
I didn't do my pre-lab the last time. You told me just do it and then. Thank you. And then I also did the pre-lab for today. I don't know if you signed that now or later, so. Okay.
This is for cleanup
Mhm.
and is this in pencil?
Yes.
Okay, no more pencil.
Oh, really? Okay.
Is it, bleed through?
Yeah.
And pencil is erasable. And you're not going to take on this being done that.
So, pen. Then.
And you put contacts, your page number, which they are, we'll put the page number. Oh, no, I'm sorry.
Yeah.
I was thankful for the page number. Just put the first page number. All you need. So it'll be 135.
Sorry, so Mr.
And what's your name on the front?
Got it. Thank you so much.
Looks good.
See you. They kind of like.
Where do you want me to put it in?
She's.
Right there.
Is. They took. Yeah. Ask Anna.
Does that make sense to?
Yeah, I've been using Slido. Yeah, so what my table time is that page here, it says. Credit for being here. This one is at 4. Yeah, I'll do the results and simply paid for activities. I don't know where I'm ever gonna be at it.
Very good.
Okay, thank you.
Okay.
Hold on, let me read the question.
You want to know something funny about this the water burning in methylene, propane, acetylene, that kind of stuff? So when welders have thick steel, they have to preheat.